Hello and welcome back to the channel. I am Benjamin Williams, and today we're going to be doing another lab within Boson NetSim. Today's lab is going to be on route selection by using routing protocol metric. So let's go ahead and read our objective for this lab. It says if a router knows two paths to the same destination and those paths are generated by using the same dynamic routing protocol, the router relies on other values such as bandwidth or hop count to calculate the best path. These secondary values are known as metric. Each routing protocol uses a different metric or set of metrics to calculate the best path to a destination network. In this lab, you will learn about Open Shortest Path First, OSPF calculates a metric to determine the best path to a destination. You will also learn how to influence route selection by modifying the metric. All right, so as we can see, we have four routers connected to each other, and they all have their different sub networks to only their specific links. So we're going to configure a IP layer 3 protocol between these routers so they can share route information with one another. We're going to be looking at OSPF in this example, and as we know, OSPF when it exchanges routes, it uses a metric of cost, and that cost is calculated based off of the status of the link and also the bandwidth of the link. Slower bandwidth links have higher costs. Lower bandwidth links have lower costs. All right. So let's go ahead and look at the commands that we're going to be going over for this example. We have configure terminal, which enters global configuration mode from privilege exec mode. We have enable, which enters privilege exec mode. We have end, which ends and exits configuration mode. We have exit, which exits one level in the menu structure. We have interface type number, which changes from global configuration mode to interface configuration mode. We have IP OSPF cost, which changes the default OSPF cost value for an interface. We have show IP route, which displays the IPv4 routing table. And we have trace route IP address, which displays a hop by hop path through an IP network. All right. So let's go ahead and look at our IP address information. We're going to keep the topology right here in the top left. So we can see R1's routing information. All right, we can see it has a serial connection, which is the connection down to router 2. It has the two fast Ethernet connections, one of them being to the 10.100.1. Based on that IP address, we could tell that is the internal subnet to PC1. We can see that it has a connection to the fast Ethernet 2.0 interface, which is the connection down to router 3. We can see the different subnet masks. We can see we also have a loopback interface on router 1. All right. So we have similar addressing schemes with each router in the lab. We also have switch information. We can see our switches have SVI interfaces configured. All right. So we can keep this table handy for troubleshooting purposes, as well as to be able to look at our topology and from there know the IP address scheme that is used within our topology. All right, so let's go ahead and get into this lab. I'm going to be doing my lab task in the top right. We're going to keep our CLI down here at the bottom. Let me refresh because it's not giving me the host name when I hit enter on the device. Sometimes Boson does that. All right, yeah, we're back and we're up. All right, so let's go ahead and read our lab task. It says task number 1, explore metric in the IPv4 routing table. It says in this task, you will use the IPv4 routing table to examine how the OSPF routing protocol metric influences path selection. You will also learn how OSPF calculates metric. All commands in this task should be issued on router 3. All right, so we need to go ahead and pull up router 3. We need to do this on router 3. If we want to examine the OSPF routing protocol metric and see how it influences path selection, and we're going to learn how OSPF calculates metric. All right, so it says two separate values directly influence which path a router inserts into the routing table: administrative distance, or AD, and metric. Router 3, which has a loopback IP address of 3.3.3.3, has two paths to R2 in this topology. If all routes in this topology use OSPF as the routing protocol with the default administrative distance, which path will router 3 insert into the routing table? So if we look at R3 in this diagram, we can see that it has a connection up to R1, which this looks like it's an Ethernet connection. And we have a serial connection down to router 4. We know we get better bandwidth through Ethernet than if we were dealing with a serial connection. So OSPF is going to see that and determine that the path to R2 should go through R1, because the path to R2 through R1 has a shorter metric cost. And that is because this link between R1 and R3. The connection from R3 to R4 has a slower serial connection, so this path is not going to be chosen. All right, so it was asking which path will router 3 take, so it'll take the path from R3 to R1 to R2. All right, so number 2, it says issue the command to trace the path that R3 takes to router 2. Through which router did R3 forward the packet? Which path to R2 do you think R3 will take? What path do you think R3 will insert into the routing table? Why do you think R3 will insert this path into the routing table? All right, so let's go ahead and do the trace route. On R3, let's do an enable. Let's do a trace route to 2.2.2.2, which is R2. And we can see that the first hop was to 203.0.113.14. So let's go take a look at our IP address table. We can see that 203.0.113.14 is router 1. So it went up to router 1 first, and then it went to 203.0.113.2. And we can see that is router 2. So it made its way to router 2. So it went to R1 first, then it went to R2. All right, so that's the path that we said it was going to take, and that is because OSPF cost through R1 has a lower metric. All right, so that is why R3 will insert this path into the routing table. All right, so number 3, it says display detailed information about the serial 00 interface. What is the bandwidth value of the link between R3 and R4 in megabits per second? All right, so on R3, let's do a show interface. We want to do that on the serial 00 interface. All right, and if we take a look at the bandwidth, we can see that we're getting 1,544 kilobits per second over this link. All right, so that's not a lot of bandwidth over this serial connection compared to speeds that we are seeing today. We're seeing gig, at least 100 megabits per second, but 1,544 kilobits per second is not a lot of bandwidth, all right, when dealing with today's networks. All right, so number 4, it says display detailed information about the fast Ethernet 2.0 interface. What is the bandwidth value of the link between R3 and R1 in megabits per second? So let's compare this serial link's bandwidth to the fast Ethernet's bandwidth. Let's do a show fast Ethernet. Show interface, I'm sorry. Fast Ethernet 2/0. All right. And now we can see over here, we're getting 100,000 kilobits per second, or 100 megabits per second. All right, so we're getting a lot better bandwidth through this Ethernet link instead of the serial link. All right, so that is the reason why OSPF chooses the route to R1 instead of the route to through R4 to get to router 2. All right, so number 5, it says based on the information you have gathered about router 3's links, how do you think OSPF calculated the cost of the links? Well, as we know, OSPF uses metric to be able to calculate the different paths to reach a destination. And as I explained, higher speed links have a lower cost and lower speed links have a higher cost. All right. So number 6, it says display the routing table and examine the metric of the path to 2.2.2.2. What does the value match? It says does the value match the value you calculated for router 3's fast Ethernet 2.0 interface? Why or why not? All right, so router 3, let's do a show IP route. All right. And if we take a look to the destination of 2.2.2.2, we can see that our metric is, our administrative distance is 110, and the metric that was calculated is 66. All right, and that metric was calculated from the link from R3 to R1, and then the link from R1 to R2 to be able to get to 2.2.2.2, which is router 2's loopback 0 interface. We can see that this route on R3 is via 203.0.113.14, which should be router 1. So if we take a look at router 1, we can see that that is a IP address that's configured on router 1. So the first hop is going to be router 1 to get to 2.2.2.2. All right. So let's see how it calculated this metric. All right. So it says right here that OSPF sums the cost of each link to the destination in order to calculate the final metric. The cost of the serial link between R2 and R1 is $64.77, and the cost of the fast Ethernet link between R1 and R3 is 1. So if you do 65 plus 1, that will be 66. So that is how we got this metric of 66. The fast Ethernet link only has a cost of 1, and the serial link has a cost of 65. All right. So that is how we got this metric of 66. All right. So let's go ahead and move on to task 2 of this lab. It says modify router selection by using routing protocol metric. It says in this task, you will use OSPF link cost to influence the path a router inserts into the routing table. As you make configuration changes, you will examine the routing table to determine how your changes affect the paths. There are a number of ways in which OSPF metric can be modified. Not every cost will be explored. Not every method will be explored. All commands in this task should be issued on router 3. So number 1, it says display the routing table. What is the cost of the path to router 2's loopback 0 interface? So if we look, we already have that up. The cost to reach router 2's loopback 0 interface from R3's perspective is 66 when looking at OSPF. All right, because we're using an OSPF route. All right, so number 2, it says issue the command to configure OSPF costs on the fast Ethernet 02 interface to use a cost of $65,535. So if we do that, that is going to make this route more than the serial route through R4. So the route through R4 will have a lower cost, and as a result, to reach router 2, R3 is now going to use router 4 because we're going to configure a higher cost from this link from router 3 to router 1. So let's go on router 3. Let's do a configure terminal. Let's go into interface for fast Ethernet 2.0, and let's do a OSPF. We want to do an OSPF process ID of 0, process ID of 1. Well, okay, let me do an IP OSPF. Yes, and I want to do a cost. That's what I wanted to do. A cost of $65,535. All right, hit enter there. Now it says trace the path to router 2's loopback 0 interface. What path does router 3 take to the destination and why? So now let's do an end, and let's do a trace route to 2.2.2.2 now. Now we can see that the first hop was 203.0.113.9. If we take a look at the routing, the IP address table, we can see that the first hop now is router 4. And that is because we configured the link between router 3 and router 1 to have a higher cost than the cost between router 3 and router 4. So as a result, router 3 is now using the route through router 4 to reach router 2. All right. And then we can see it reached R2 in the next hop. If we take a look at the IP address information, we can see that 203.0.113.5 is router 2's serial 01's interface. So it reached router 2. All right. So now it says display the routing table. What is the cost to the path of router 2's loopback 0 interface now? How was this cost calculated? So now if I do a show IP route, if I take a look at the 2.2.2.2 address, we can see that the metric that is used is 129. And that's because we did 65 plus 65, which is both of these serial links. All right, so it says how was the cost calculated? It says the cost of the path to router 2's loopback interface is now 129 instead of 66. The cost was calculated by adding the cost of the serial link between router 3 and router 4 to the cost of the link between router 4 and router 2. So that is both of the serial links right there that we can see from the topology. Now it says remove the IP OSPF cost 65,535 command from the Fast Ethernet 2.0 interface. So let's go back into router 3. Let's do a configure terminal. Let's go into interface Fast Ethernet 2.0. And let's do a no IP OSPF cost of 65,535. All right, that is negating what we just did. So now it says trace the path to router 2's loopback 0 interface. What path does router 3 take now? Well, since we removed this command, now it should go back through router 1 because router 1 has its original metric cost, which was 66 to reach router 2. So now if we do an end and we do a trace, if we do a trace route to 2.2.2.2, we can see now we're going back through 203.0.113.14, and that should be a IP address on router 1. Let's take a look, and we can see that is an address on router 1. And then we got to 203.0.113.2, and that is the serial 00 interface on router 2. So it reached router 2. All right. So now it says, lastly, display the routing table. What is the metric of the path to 2.2.2.2? We took a look at this a minute ago, and it should be 66, but let's confirm that. Let's do a show IP route. If we take a look at the 2.2.2.2 address, we can see that the cost is 66. So we just confirmed that, and we can confirm that it's OSPF by looking at that administrative distance value. All right. So this looks to be the end of the lab. Let's hit grade, and hopefully we did everything correctly. And we did. So I appreciate you guys for watching this one, and I'll see you in the next one.